Good morning, students. So, in the last class, we studied about the molecular orbital theory. Okay. So, in the today's class, we are continuing with that. In that molecular orbital theory, I already explained you the formation of hydrogen molecule, the formation of the helium molecule. So, hydrogen molecule, we got the bond order 1, means it is stable. Okay, in helium we got the bond order 0, means He2 molecule is unstable because there is no bond between helium and helium. Okay, the question they are going to ask is explain why helium molecule is not stable. Okay, or explain the MOT theory of helium molecule. Like that they will ask. Whether they mention MOT or they may directly ask. Okay, let's continue with the next one. So lithium. Okay, so lithium atomic number is 3. Configuration is 1s2, 2s1. So students, we need to consider one lithium, but in molecular orbital theory, we have to consider lithium molecule. Lithium atom, this is lithium molecule. Each lithium consists of this configuration. And remember, how to write the configuration initially I'll write. If 1s orbital is there, always write sigma 1s, sigma star 1s. If 2s is there, then sigma 2s, sigma star 2s. Are you getting? For one orbital, we are going to write two molecular orbitals. For one orbital, whatever it is. From one lithium this, from one lithium this and this. Are you getting? Remember, and why I am telling this is if 1s orbital is there, then in the molecular orbital, sigma 1s, sigma star 1s will be there. 2s orbital is sigma star 2s. Okay, this is to write. Still we don't know how many electrons are there. Okay, so now listen. Okay, another one thing I said. Listen, for one molecule of lithium, how many electrons are there? 3 electrons. For lithium, atomic number is 3. Atomic number means number of protons and number of electrons. Number of electrons here is 3. Here lithium 2 molecule means from the molecule 6 electrons are there. For one lithium, 3 electron. For 2 lithium atom, 6 electron. Then here write 1, 2, 4, 6. This is the configuration. Okay, without molecular orbital diagram, I am writing the configuration. Next write orbital diagram here. As I told you, this is the increasing order of the molecular orbital. Increasing order of energy. So listen, 1s orbitals are here. This is 1s, this is 1s. So this is one lithium, this is another lithium. Okay, in lithium molecule, 1s orbitals consist of how many electrons? 2 electrons. In configuration we used to see, don't think from where the electrons are coming? From the configuration. From one lithium molecule also consists of this electron, another lithium also consists of this electron. Okay, next, if two atomic orbitals gets overlap, after that I write, so one is 1s orbital, next one is what? 2s orbital. 2s orbital is slightly greater in energy. This is 2s, 2s. Okay, so 2s orbital consists of how many electrons? 1 electron. So write 1 electron here. Okay, listen. If two atomic orbitals of same energy means 1s overlap combined with 1s, 2s combined with 2s. 1s never combined with 2s. Okay, atomic orbitals of same energy are combined with each other. So if the two atomic orbitals combine, then how many molecular orbitals will form? 2. We know that. How many atomic orbitals will combine? That much of molecular orbitals will form. Here one is from one lithium, another Okay, so this is sigma 1s, this is sigma star 1s. Similarly, here also two molecular orbitals will form. Okay, this is sigma 2s, sigma star 2s. So students remember here 1 means 4 electrons are there. Initially lower energy fill up takes place followed by higher energy. So here 4 electrons, here 4 electrons, satisfied. Here 1 electron is here, this is the lower energy, another electron will pair here. Okay, means sigma 1s electron consists of sigma 1s orbital, sorry, molecular orbital consists 2 electron. Sigma star 1s consists 2 electron. Sigma 2s consists 2 electron. Here, sigma 1s 2, sigma star 1s 2, sigma 2s 2. Everything follows same. Before writing the molecular orbital diagram, you can easily write the configuration without writing the diagram. Based on this, you just write the molecular orbital diagram. This one clearly gives to which orbital how many electron is to be entered. Okay, later we'll explain. So we got this and this. This is MOT diagram, this is MOT configuration, molecular orbital configuration. This is molecular orbital diagram. The next one is bond order. Listen, this is first one, this is second one, third one is bond order. Bond order means number of electrons in bonding molecular orbital minus anti-bonding molecular orbital divided by 2. Okay, bonding molecular orbitals means this sigma, the orbitals without star. Okay, how many are there? This one. Here 2 electron, here also 2 electron. So 4 minus here antibonding means with star 2 electron divided by 2. That is 2 by 2 means 1. Means molecule is lithium single bond lithium because bond order is 1 means bond order means the number of bond between the atoms. How much? 1. The molecule is equal to lithium. Single bond lithium. Molecule is unit. Next, the fourth one, magnetic property. So this is paired electron. Listen, this is paired electron. This is also paired electron. This is also paired electron. Means it is diamagnetic. It is diamagnetic. Okay. So students, same will follow for this. Listen, another one thing I will say. Once the orbital is completed, like 1s2, that is completed. 2s is the valence shell. So here listen, except this, if you find bond order for this, 2 minus 2 divided by 2 means 0 by 2, that becomes 0. So another one thing what I am telling is, no need to write the molecular orbital diagram for complete shell. 1s K shell, it is already completed. No need to write the molecular orbital diagram for that. 2s1 is the valence shell. Consider this. Okay, listen, if you break this molecule here, you just consider this one as the configuration. Now here, bond order is how much? Sigma electrons, sorry, bonding electrons minus anti-bonding by 2 means 1. Everything is same. So no need to consider the complete configuration here. When it comes to p orbital, we need to write a bigger structure. Because if we want to write p orbital here, we require more space. At that time, we don't need to write this configuration. Are you getting? So the next one is boron molecule. Okay, boron molecule. And instead of boron, important one you take, that is C2, carbon molecule. So listen, one carbon configuration is how much? 1s2, 2s2, 2p2. Now listen, 1s orbital is there, then what must be the molecular configuration? 1s orbital is there, then it is sigma 1s, sigma star 1s. If 2s orbital is there, then it is sigma 2s, sigma star 2s. If 2p orbital is there, in the last class I gave you the configuration up to nitrogen 5 comes first. Correct? Up to nitrogen 5 comes. 2px is equal to 5, 2py. Next, sigma 2pz, pi star 2px is equal to pi star 2py, sigma star 2pz. This is the way to write the configuration. You have to write completely bonding as well as anti-bonding. Are you getting? For 1s orbital, sigma 1s, sigma star 1s. For 2s, sigma 2s, sigma star 2s. For p, you know, 3 orbitals are there in p, px, py, pz. So in that, 3 are bonding, 3 are anti-bonding. Understood? This is the way to write the configuration. Remember that up to nitrogen, this configuration follows. After nitrogen, another one will follow. Later I'll explain which configuration is. Okay? So here, for one carbon atom, atomic number is 6. One carbon atom, atomic number is 6. Means number of electron is also equal to 6. Are you getting? So here 2 carbon atoms are there. Then how many electrons? For one carbon atom, 6 electrons. For 2 carbon atom, 12 electrons. Just divide. 2, 4, 6, 8. Okay? Listen, initially, here the thing changes. These are of equal energy. Initially, 1 electron. Then 2, 4, 6, 8, 9, 10. Next, 11, 12. Initially, these electrons are singly filled. Later, they are paired. You cannot write directly 2 and 2u. 2, 1, you cannot be possible. If 10 electrons are there, assume 2, 4, 6, 8. Okay, 10. You cannot write like this. You have to write 1 electron here, 1 electron here. Because they are of equal energy. Pi orbitals are initially singly filled, followed by period of. Okay, this is the configuration. Now write the diagram. Just consider here the molecular orbital diagram. Okay, so this one is 1s orbital. Okay, this one is, of course, they form 2 molecular orbitals. I will just write here. Next, 2s. One s orbital. This is 2s orbital. Next, so in that the first one will be the next is don't confuse in that how to write the diagram. Listen here. Sigma 1 is sigma star 1 is sigma 2 is sigma star 2 is after pi comes. They are in equal energy. So pi orbital we are writing here. Later sigma only 1 orbital. Next, sorry. Here pi star px, pi star py, later sigma star. According to configuration, we are writing the diagram. Okay. So listen, in 1s orbital, how many electrons are there? This is one carbon, this is one carbon. For 1s orbital, 1s2, 2s2, 2p2. Correct? Here also 1s2, 2s2, 2p2. Now, of course, here 4 electrons are there. This is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px, pi 2py, sigma 2p set. Next, pi star 2px, pi star 2py, sigma star 2p set. Listen here. So here, of course, completely filled because 4 electrons are there. Here also 4 electrons are there, completely filled. Okay, next here, listen. Listen here. 4 electrons are there. One fill up takes place here. Next year. Next year. Next year. This is the way to fill. Initially, singly electrons are filled, followed by the pairing carbon. Okay. So then here, sigma 1s, 2 electrons. Compare the configuration. Sigma star 1s, 2 electrons. Sigma 2s, 2 electrons. Sigma star 2s, 2 electrons. Pi 2px, 2 electron. Pi 2py, 2 electron. This is the configuration of the molecular orbital thing. And these are having 0, 0, 0. So students, the next one is bond order. Remember, and consider bond order for all these and only for this or this valence shell 2s and 2p shell. Okay, listen, if you consider this one and just mark which are bonding, this is bonding, bonding, these are all bonding. How many electrons are there? 2, 4, 6, 8. Okay. Here in the bonding molecular orbital minus anti-bonding molecular orbital electrons divided by 2. The total 8 electrons are there in bonding. Next, this one is anti-bonding. 2, 4. Okay. Then it is 8 minus 4 means 4 by 2. That is 2. Bond order is 2. This is complete molecular orbital diagram. Listen here. If you consider, this is completely shell, I just remove this. This is also complete configuration. Of course, 2s, 2p. This is 2p. You may consider this or allow this. It's complete agreement. Either 0 is if you not considering this, then calculate bond order here. Number of electrons in bonding is 4, anti-bonding is 0, divided by 4 by 2 means 2. Means the valence shell, last orbital itself gives the correct bond order. No need to count all the, electrons present in the molecule. Valence configuration is enough, 2s, 2p. Alone 2p sometimes give the correct answer. Means one orbital is completely filled, the bond order becomes 0, so no need to write that. Are you getting? So students, another one is, remember, molecular orbital diagram, which way you are writing, that doesn't matter. Whether you are writing 1s, 2s or alone 2p, it doesn't matter. But the configuration starts from 1s, 1s, 2s, 2s like that. While you are writing the configuration, you must and should need to consider this completely shell also. You cannot write directly pi to p2, pi to py. That's wrong. Configuration carries all the orbitals, but the molecular orbital diagram only valence. Understood? Okay, this is C2 molecule. Here the bond order is how much? 2. So molecule is C double bond C. That is the C2 molecule. Understood? Okay. So the next one is magnetic property. That is what? Diamagnetic. Why it is diamagnetic? Because all the electrons here are completely means paired. Okay. So this is C2 molecule. Which are important for examination, definitely I am writing students. You can write it for each and every molecule. If bond order becomes 0, then it is okay. So listen. Next one is N2 molecule. Okay. For each nitrogen, number of electrons is equal to 7. So configuration 1s2, 2s2, 2p3. So next one is first one is what? Configuration. If one s orbital is there, remember, one s orbital is there, then how many orbitals will come? Molecular orbitals? Two. One is what? Sigma 1s, sigma star 1s. Correct? Next, 2s orbital is there. Then it is sigma 2s, sigma star 2s. Next, 2p3 orbital is there. It is nitrogen. That means pi comes first. Pi to px is equal to pi to py. So next I will take here sigma to pz, pi star to px is equal to pi star to py, sigma star to pz. Okay, this is the trend. Next, listen, here we are not considering this, not considering this, we are considering only p orbital. Because this is also completely filled s orbital, this is also completely filled s orbital. Valence is what? 2p3. So we are writing only molecular orbital diagram for p orbital. Or you may write the molecular orbital diagram for both 2s as well as 2p because this is completely a valence issue. Are you getting? You have to write the molecular orbital diagram for 2s as well as 2p for your convenience. If you want to write, you can write. But the diagram is for one nitrogen, 7 electrons. For two nitrogen, how many electrons? 14. First to divide them here. 2, 4, 6, 8, okay, 10, 12, 14. Understood? Listen here. 2, 4, 6, 8, 10, 12, 14. 14 electrons are there. Okay? Now, so listen. Here also you may easily calculate bond order. How? Whatever we represent with star, those are antibody. Without star, they are bonding. Count how many electrons are there without star. 2, 4, 6, 8, 10. 10 electron minus in bonding, sorry, in antibody means with the star 2, 4 divided by 2, that is 6 by 2 means 3. Initially we know bond order is this much. Later we will prove it. Okay. Remember here the bond order must be 3. Write the diagram here and write complete diagram. Nitrogen, nitrogen. Valence shell I will consider. This is 2s. This one is 2s orbital means how many electrons are here? 2 electrons. Just see the configuration 2s2, 2p3. Okay. Here two orbitals are combining Then they form two molecular orbitals. Among them, one is sigma 2s, another one is sigma star 2s. So next, which one comes first? Pi comes first. Here two pi orbitals. Later, sigma orbital. Later, pi star orbitals. Next, sigma star orbitals. Okay. Okay. So the next thing is filling up of electrons. Here, two electrons. Next here, listen. Initially, one electron, two electron, three, four. Initially simply filled, later paired. So remaining is how much? Four electrons are here. Two it is. So this is pi to px, pi to py, sigma to pz. This is pi star to px, pi star to py, sigma star to pz. Okay. So next the bond order. Bond order is equal to bonding molecular orbital minus anti-bonding molecular orbital electrons divided by 2. So here, this one is bonding, this one is bonding, this is also bonding, this is also bonding. How many electrons are there? 2, 4, 6, 8. Minus. Anti-bonding is this one. How many electrons are there in anti-bonding? 2 divided by 2, that is 6 by 2, that is 3. And just we derived from this, bond order is 3. So what I am telling is, from the molecular orbit configuration only, we can easily write. Okay? So we can easily write what is that configuration, bond order, the magnetic property, everything we can easily write. Okay, so this is how to find out or explain. In the NEET examination, this one follows. If you know this molecular orbital diagram how to write, then you can easily answer. So students, while I am doing or explaining the NEET session based on chemical bonding, at that time clearly in depth I will give. Some formulas are there to find out that, okay? Everything I will give, remember. So for theory, 3 marks, if they clearly ask, write the bond order and magnetic property of any molecule with MOP. Then you need to write the diagram, this formula, this configuration, everything. That carries 3 marks. For configuration 1 mark, bond order 1 mark, paramagnetic character or diamagnetic character 1 mark. For that, no need to write the diagram. If they ask configuration, bond order and magnetic property. If they clearly ask, explain the structure of any molecule by MOP theory, then you need to write the diagram. There is a difference in that, okay? In the question framing also. This is what okay, here all are paired up, then it is what? Diamagnetic. Okay, so this is all about N2 molecule, important for 3 months, often asking question. Understood? The next is, we will get O2 molecule. So oxygen atomic number is 8. Configuration is 1s2, 2s2, 2p4. Okay, then the first one is the configuration. How to write? Here sigma, sorry, 1s is there means, repeat it. If 1s orbital is there, how many molecular orbitals will form? What are they? Sigma 1s, sigma star 1s. Correct? If 2s is there, then sigma 2s, sigma star 2s. Listen, the thing after nitrogen, what will change? In p orbital here, pi comes first, followed by sigma. But after oxygen, means after nitrogen, first sigma comes. Means sigma 2pz pi 2px is equal to pi 2py. Pi star 2px is equal to pi star 2py and sigma star 2pz. Are you getting? What is the configuration changes here? Up to nitrogen, pi 2px, pi 2py comes first, later sigma. Because listen, until these whatever the electrons fill up places, that is equal in energy. They are not entering pi orbitals here. Up to nitrogen, they are in what? What is it? In bonding molecular orbitals only, not in anti-bonding. Okay, so initially for nitrogen, this is the configuration. After nitrogen, means after the atomic number 7, it may be 8 and so on, so on, so on. After 8, so the configuration follows. Sigma comes first, followed by only these two will change. Remember? So listen here, only this position. Remaining all are same, only this will interchange. Okay, so now listen here. For one oxygen, 8 electrons. For one oxygen, 8 electrons. For two oxygen, 16 electrons. Divided by 2, 4, 6, 8, 10, 12, 14. Listen here. 5 star are there. Only 2 electrons are there. 15, 16. What I told? Initially, they singly filled, later they paired up because they are equal energy. 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16. Understood? Okay. Listen, if you write a molecular orbital diagram, no need to write for this, you just write to this. Okay? And just consider the orbital here. Okay, listen here. In 2p orbital, how many electrons are there? 1, 2, 3, 4. Here also 1, 2, 3, 4 for each oxygen atom. Okay, next. Here how many orbitals will come? Of course 6. The first one is sigma E. Sigma 2pz. Correct? Later pi orbitals. That is pi 2px, pi 2py. Later, this is pi star 2px, pi star 2py. Later, sigma star 2p. This is the orbitals. Now, so initially 1 electron, 2 electron. Because 8 electrons are there, take the count, 8 electrons, among 2 are here, remaining is 6. Here 1 electron, 1 electron. Remaining is 4. Again they paired up. Remaining is 2. They are in equal energy, 1. Just take the configuration. Sigma 2p2, pi 2px2, pi 2py2, pi star 2px1, pi star 2py2. But the configuration in the diagram, everything follows the same. Now, bond order. So listen, initially check the bond order here. From this, initially you check bond order from this diagram. This is whatever the thing underlying here, that is bonding molecular orbitals. How many? 2, 4, 6, 8, 10. Minus this is 2, 4, 5, 6 divided by 2. 4 by 2, that is 2. Means oxygen is this type of molecule. This is from configuration. Now check here. Bond order is equal to. Here we are considering complete configuration from 1s. Here we are considering only valence. Okay. Bond order. Here this is the bonding, bonding, bonding. This one is anti-bonding, anti-bonding. Correct? So in bonding, how many electrons are there? 2, 4, 6. In anti-bonding, how many are there? 2 divided by 2, that is 4 by 2 is equal to 2. So bond order is same for all. So the molecule here is oxygen double bond oxygen. This is first one, this is second one, this is third one. The fourth one is magnetic property. So students, here magnetic properties are here one orbital. So the electrons in the pi orbitals are singly bonded. If they are singly bonded, they are paramagnetic. If they are singly bonded, that is paramagnetic. Understood? So this is all about the molecular orbital diagram. Very important thing is, so write down the molecules. Hydrogen molecule configuration is important. He2 molecule configuration is important. Lithium 2 molecular configuration. C2, next N2 and 6th one O2. Only these often they are going to ask. Explain the molecular orbital theory diagram of H2, He2, Li2, C2, N2 and O2. Understood? So up to N2, this is the electronic configuration. After nitrogen, that is the electronic configuration. Remember that. Okay. Next, another one. So listen, if the different atoms they are given, for example, it may be CO molecule taken. One is carbon, another one is oxygen. We don't know. Then how to do? So we don't need to write the structure. Listen, one is carbon, another one is oxygen. Okay? If that type of molecules are there, this one follows. Sigma 1 is, sigma star 1 is, sigma 2 is, sigma star 2 is. Here which one comes first? That depends. So listen, this carbon is before nitrogen, this oxygen is after nitrogen. Means if any one atom is there, that is after nitrogen, then the sigma to be Z will come first. Are you getting? CO molecule is there. This carbon is before nitrogen. I told you, before nitrogen, 5 will come first. After nitrogen, sigma will come first. Here oxygen is also there, carbon is also there. This is before nitrogen, this is after nitrogen. Then also, after nitrogen, pairs. Then this is pi to px is equal to pi to py. Pi star to px is equal to pi star to py. Sigma star to pz. Now, how to write the configuration? You know, this is different orbital, this is different orbitals. The configuration, this is different, this is different. Just count the number of electrons. Here the number of electrons in carbon is 6. In this oxygen is 8. 8 plus 4, how many electrons? 14 electrons. 8 electrons from oxygen, 6 electrons from carbon. 8 plus 6, 14 electrons. Just to divide here. 2, 4, 6, 8, 10, 12, 14. In that, mark bonding and anti-bonding orbitals. Okay. Now, the bond order is equal to bonding molecular orbital electron minus anti-bonding molecular orbital electrons divided by 2. How many bonding molecular electrons are there? 8. 2, 4, sorry, 10. 2, 4, 6, 8, 10. Minus. Here 2, 2, 4. Divided into 6 by 2 means 3. That is, molecular is C triple bond O. Understood? So number of electrons here is equal to 14 means in N2 molecules also number of electrons is equal to 14. Okay? What is the bond order in N2? N triple bond N. No matter whether it is a same nitrogen molecule, whether it is homoatomic or polyatomic or diatomic. If the number of electrons are equal, then the bond order is also equal. CO is different, N2 is different, but both are consisting of 14 electrons only. Are you getting? Then the bond order is 3. Here also 3, here also 3. This is the way to write the molecular orbital configuration and calibration of the bond order. And listen, if you want to write the magnetic property here, here 2, 2, 2, 2, no one is a single electron. Of course it is diamagnetic. Understood? Okay. So this is about the configuration of the molecules. Anything doubt in this? Oh, students, this is the easy trick. Writing the configuration is dividing the electrons, calculation of this, and the calculation of the, identification of the magnetic property. Very easy thing. Okay, just remember, this is for NEET. Whatever I explained with the diagram, that is for theory examination, very important. And by completing this MOT, this chemical bonding chapter is completed. Very important chapter, go through it. Okay, thank you.